So before we start discussing proofs, we first need to talk about inference rules. Because inference rules are the building blocks of an argument, and a proof is nothing but a series of arguments. So let's go ahead and, since I'm talking about arguments so much, define what I mean by an argument. So let's go ahead and break down this definition right here. An argument in propositional logic consists of a claim. And this claim right here is usually called the conclusion. So this claim right here, it is a proposition, and we refer to it using the name of a conclusion, followed by one or more propositions right here. And so by propositions, these are logical propositions, and we usually refer to these as either the premises or the hypotheses. So these are logical statements right here. We refer to them with the names as premises or hypotheses. Now, an argument is called valid if when we set all of these premises or hypotheses, these propositions right here, true, then that implies that this conclusion or that claim right there is true. So I think it'd be helpful here to go ahead and look at an example. So let's look at an example of an argument. Okay, so here's an argument right here. The conclusion I'm given is Q, and you can think of Q to be any logical proposition that you want. For example, we could think of Q as it is warm, and we have two hypotheses right here. The first hypothesis is P, and the second hypothesis is P implies Q. So if you wanted to, you could think of the P right here being the sun is shining, and so this P implies Q right here would be something like, if the sun is shining, then it is warm. Now, typically, whenever you write an argument, and for example, in Rosen 1.6.2, the way that this is represented symbolically is as follows. So we use a little table format that looks like the following. So we use this tabular format right here, and what we do is we put our hypotheses up here at the top of this little table right here, and then at the very bottom we put our conclusion. This little three dots right here, the way that you read that is therefore. So the way that you would read this argument is if P and P implies Q, therefore Q right here. And we want to see, is this argument right here a valid argument? So to make it concrete, this argument, if I let Q be my statement, it is warm, P, the sun is shining, P implies Q, if the sun is shining, then it is warm. Is it a valid argument to say that if the sun is shining and If the sun is shining, then it is warm. Can I conclude that it is warm? Is that a valid argument? Well, let's go ahead and go back to our definition of what a valid argument is. So that means we'd have to set all the propositions true. All our propositions, our premises and hypotheses in this case are P, and P implies Q. So to see if this is a valid argument, what I'm going to have to do is take all of my hypotheses right here and set them equal to true. And then what I want to see is, does that imply that my conclusion is true? Well, let's go ahead and try to check and verify this. So I could do that by, for example, using a truth table. So if I wanted to, I could write a truth table, and here I have a P and a Q. And you remember the definition of P implies Q for this truth table right here. What are we going to do with this truth table to figure out if this is a valid argument or not? Well, I know P here is true. And so since P is true, I'm only considering these couple of entries in my truth table. So since P is true, I really only have to look at this part of my truth table, and I can completely ignore the last two rows right here. And then lastly, I know that P implies Q is true. And since P implies Q is true only in my first row right here, that means I'm actually really only looking at this first row right here. And if we look at this row, does that imply Q? Well, yeah, right here, Q indeed is true right there. So what we can conclude is if P is true and P implies Q is true, then Q is true. Great, so we've been able to take our definition of what a valid argument is, and by using a truth table in this case, go ahead and conclude that this particular argument right here is valid. So what inference rules are going to be is a collection of short, valid arguments like this that will allow us to construct and build larger arguments and eventually get to proofs. And so that's why we are going to be considering inference rules.